Hey everyone, welcome back to my YouTube channel, and in this video we're gonna solve this Pillage exposed RDS instances lab from ownedlabs.io. This lab is related to the Amazon RDS service, that is relational database service, and here we have our entry point, that is RDS endpoint, and here we have to submit our flag. Let's see the scenario. In the backdrop of rising cybersecurity threats, with chatter on Telegram channels hinting at data dumps and paste bin snippets, exposing snippets of configurations, and the huge logistics is taking no chances. They have enlisted your team's expertise to rigorously assess their cloud infrastructure, armed with a list of IP addresses and endpoints. A lead emerged, that is an RDS endpoint, and our mission is to deep dive into this endpoint security and identify any security issues before threat actors do. And as usual, the lab prerequisites are same, like basic Linux command line knowledge is required. Difficulty is beginner and focus is on red team. And here we have the real world context. So according to AWS, Amazon Relational Database Service is a web service that makes it easier to set up, operate, and scale a relational database in the AWS cloud. And here we have these database instances that are supported by the Amazon RDS. We have Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle Database, and SQL Server. And these are their respective port numbers. So in this lab, we have to perform the brute force attack by using the mysql-brute script. Okay. And we all know what is brute force attack. The brute force attack is a popular cracking method. It involves repetitive attempts of trying various passwords combination to break into the website. So we're going to use the mysql-brute script to perform this brute force attack. Okay, so let's start off with our enumeration. Let me copy the RDS endpoint. Okay, so let's open the terminal. So let's write nmap -pn. So we're going to use the following command for scanning the port numbers, that is MySQL port, Postgre, Microsoft SQL Server, and Oracle Database. And we have provided our RDS endpoint. Okay, let's hit enter and let's wait. Yeah, as you guys can see, the one port is open, that is MySQL port is open, 3306. That's cool. So let's try to log in. MySQL-edge, that is our host, and our host is our RDS exposed endpoint. -u is root, and the port number is 3306, right? So let's hit enter, and root will be the password. Access denied for user root. Okay, so no problem. It's time to go with the brute force attack, and I already have this script. Okay, I've already downloaded the script that is in my lab 5 exposed RDS instance folder. So let me clear the screen, and I have this mysql-creds.txt file. Let me get it. So these are the username and password. Now it's time to perform our brute force attack. So let me clear the screen first, and I'm going to use the Nmap. So here we are using the PN switch that will skip the host discovery part and assume that the target is up, and the port number is our MySQL port. This switch, that is script equal to mysql-brute, we are giving this instruction that execute the mysql-brute script. Okay, and here we are setting the arguments of the brute force script that include the brute delay, that will be 10 seconds between the attempts, and we are also specifying the mode as credentials, that is creds, and the brute.cred file, that is our mysql-creds.txt. okay, this is the name of the file, and then we have to provide our RDS endpoint. Okay, that will be our target host name, or instead of this you guys can use IP address or host name as well, but in this case we are using this endpoint. Okay, so let me hit enter. So this script is attempting to guess valid credentials by trying different username and password combination listed in this MySQL creds file. Okay, and we have got our valid credentials, that is db user 1, 2, 3. So we have got the access of the database, right? Let's copy this credentials and paste it here. Okay, let me clear the screen. Let's write mysql -h is for host and the DB user is our username. Let's write P and let's hit enter. 1, 2, 3 is the password. Let's hit enter. And yes, we have got access to this MySQL database. Okay, so let's check the permission of this user with the help of this command, that is show grants for DB user. Okay, this will be the command to check the permissions of this DB user. Let me clear the screen and now let's hit enter. Okay, so this DB user has this read access to this user info database, and these are the tables, that is flags and users. Okay, so now we have this read permission of this flag table. So let's go and collect our flag first. So I'm gonna use the use command, use user info database. Okay, don't forget semicolon and let's hit enter. Okay, now the user info database is selected. Let me clear the screen and now let's write the show tables command, show tables and semicolon. Let's hit enter. And yes, we have two tables, the flag and user. So let's write select star from flag, flag semicolon, hit enter. And we have got the flag. So let's copy this flag and let's go to our lab and let's submit it. SSRF token mismatch. Okay, let me just refresh it. Okay, now let's paste the flag here, submit it. Yeah, congrats, you have successfully completed the challenge. Cool. Now we have to check this users table. Obviously we will get some sensitive information, so let's write select star from users and semicolon. Let me clear the screen first. Okay, so we have this result, like these are the email addresses, first name and last name. Okay, but I cannot see the field names, right? So for that I can use this command. Let me clear the screen. That's slash capital G. It will present the output in a more vertical and detailed format. Okay, so we don't have to scroll up to see the fields. So let me hit enter. And yes, we have got the field names. User ID is 875 Lauren. I don't know how to pronounce this last name, but here we have the email address, password, IP address, credit card information, like credit card data. So this is how you can represent the output in a more vertical and detailed format instead of the traditional tabular form that we have seen earlier. Okay, so we have got access to the sensitive data. Now let's talk about the defensive strategy, right? So we all know that securing exposed RDS instances on AWS is critical to prevent unauthorized access and potential security breaches. So here are 5 defensive recommendations. The first one is configure network security groups and VPC. You need to limit access to your RDS instances by configuring network security groups to only allow traffic from specific IP addresses or ranges. And you need to place your RDS instances within the virtual private cloud and ensure that only necessary traffic is allowed to reach your RDS instances. And as per the design architecture, we have to launch our RDS instances in a private subnet, and it ensures that it does not have an internet access, right? And we have seen this particular RDS endpoint is publicly accessible. And yes, use proper NACL rules and security groups to secure your RDS instances. Next up, we have use IAM database authentication. Whenever possible, use IAM database authentication, and this will allow you to connect to your RDS instances using AWS Identity and Access Management. And this will allow you to connect your RDS instances using IAM users or role credential instead of a password. IAM authentication also provides a secure and scalable way to manage database access. Next up, we have to use strong authentication and encryption options. We need to enforce the use of strong passwords for database users and also enable encryption for data at rest using AWS Key Management Service, that is KMS, and for data in transit, use SSL and TLS. That will be a more secure way to handle your data, and this will help you to protect sensitive data even if unauthorized access occurs. Our next point is related to monitoring and auditing. Make sure that you use CloudWatch logs and AWS CloudTrail to monitor and audit your RDS instances. So monitor database logs for suspicious activities and use CloudTrail to track API calls made on your AWS accounts, and regularly review and analyze logs to detect any abnormal patterns or potential security incidents. Last but not the least, let's talk about backups and batching. You need to enable automated backups for your RDS instances to ensure that you can recover data in case of accidental deletion or corruption. So keep your database engine and RDS instances up to date by applying the latest patches. And yes, make sure that you regularly test the restoration process to verify the backups are working as expected. And remember that security is a multi-layered approach, and implementing a combination of these recommendations can significantly enhance the security posture of your exposed RDS instances on AWS. So there you have it, folks, the best practices for securing Amazon RDS instances on AWS. And with this, we have solved our lab, okay, the Pillage Exposed RDS Instances lab. I hope you liked this video, guys. If you did, then please share this video with your friends and your colleagues. And make sure that you guys are subscribing to my YouTube channel. And we'll see you in my next video. Till then, take care and keep learning. Bye-bye.